Great to be here. I'm Zach from Fastly. Today we're going to be talking about simulating live stream piracy and some new approaches that we can look at for mitigating token abuse, token sharing as part of your sort of anti-piracy strategy. This is an example of a live event we've had in the past. This customer didn't have rights in a particular region, yet we still saw multiple terabits a second of pirate traffic, being streamed during this event. This is, unfortunately, is a very regular occurrence. So you might be asking, and if you've seen me before, why are we still talking about this? Why are you still talking about this? This is still a very complex whack-a-mole game. I talked about sort of the end-to-end sort of ecosystem and all the pieces at my talk in Demuxed in London last year. But really, we're just seeing piracy increase. In recent times, with certain sporting events, we've seen piracy events, peak over 30 terabit. In some of these cases, 60, 70, 80% of that 30T, we believe from some of the data we have was piracy and not legitimate traffic on events. So scale of this is really increasing very, very quickly. This requires a really sophisticated sort of toolbox, and thinking about sort of your tools that you're using to combat piracy really in an end-to-end sort of approach, and not just relying on one piece or one set of technologies. And the pirates adapt very quickly. Once you put in some blocking or use some approach, they'll look at adapting very quickly. There's very organized groups. So, we need to start moving quicker if we want to stay ahead of these sort of issues with piracy. So let's just do a really quick refresher on some of the common pieces of an anti-piracy sort of workflow. DRM is obviously very common. This is required in a lot of, premium sports rights holders contracts. This provides, secure key management. This makes it on device harder to, extract the video, just even screenshot, you'll get a black screen. But what we're seeing in this space now is there's many weak and cracked CDMs and devices out there, and the pirates are finding these devices. Unfortunately, publishers don't always want to deprecate every old device out there. You might still have a reasonable number of, your audience and viewers on some of these older legacy devices. So now the pirates are finding these, they're extracting keys, and then they're able to sideload these keys in. So where you're able to, thinking about your DRM policies, where are you supporting hardware versus software, DRM CDMs, what devices are you restricting and blocking access to if they're known, weak and cracked, those are important as part of your DRM strategy. Token auth, is really important then on the delivery side on your CDN, to make sure that you're restricting who your CDN is delivering the streaming objects to, your manifests, your segments. This is fairly complex though still to support across multiple CDNs. Common access token now is helping to unify some of that space. But one of the big things here, and we're going to really deep dive into this today, is that there's still approaches and still ways for pirates to get these streams, get these tokens, and then still share and reuse those tokens across large scale set of devices. And then finally, we're seeing forensic watermarking starting to be required more in certain, particularly in Europe at this point. This embeds non-visual watermarks, but this adds a lot of complexity in your encoding pipeline, your packaging. Now you're storing multiple sets of content. That's splitting your cache footprint. You add additional logic in the edge for giving a particular user an A and B pattern. And then, at times, depending on your audience size, this can still require long detection times and expensive and complex services to go out and find the content. So there's definitely still challenges in using watermarking effectively. So, what we're going to focus on today is some of the limitations of token auth and some approaches that we can think about now to make some of this a little bit more robust or make it easier to detect where tokens are being used and abused and shared. So today it's still fairly easy to intercept and extract these tokens on a device. They're usually there's an authorization API that will generate a token that'll be included either like in a path, a query parameter, a cookie, a header, something like that. So if you're on a app or you're on a web page, it's still fairly easy to extract those. That can then be shared as part of the URL to these pirate playback players, which can be web devices. We're seeing more Android APKs. Many of them still seem to be doing web views today, but in a standard workflow, an edge check still may not know that the token. It will just verify the signature in the token, verify expiry times and other attributes, and go, cool. It's probably valid. You can add restrictions now in common access tokens for things like geo or IP address, but some of those can be fragile if you have users that are moving between networks or other things. So and then the observability can still be challenging to scale here. Particularly during big events, you might have many millions of RPS. So we're going to talk about some other approaches we can use here. As I mentioned, log data is a common approach here to finding token abuse and reuse. But that's grows very, very quickly. So, this is assuming a event with 10 million concurrent viewers. Let's say we had 2-second segments here. With how manifests and segments are requested, with retries that might happen if you have an additional manifest request that didn't get a new manifest and needs to poll again, it's not uncommon to, in this scenario, see us getting up to, 15, 20 million peak RPS. If we start to assume a log message size around 1 kilobyte, that means that we get to the 72 terabytes an hour, or nearly 270 terabytes for a 4-hour event. This is a lot of log data now that we have to get delivered from each our CDNs, and maybe multiple CDNs. We have to ingest this, process an index, then we have to write and run queries. Then we might need to get that to a dashboard or an alert for someone to take action on. And then now we're also thinking about how do we add sort of AI analysis into working with some of this data. So all of this is happening before any analysis or action, and is a huge needle in the haystack sort of problem. Let's talk about building an approach to simulating piracy. In the wild during an event, there's going to be a lot of people out, a lot of streams out there, a lot of individual requests. So in thinking about streaming piracy, the way I started to approach this and building a framework and a toolkit was being able to generate common access tokens. So these are generated per session. There's a unique subscriber claim. So there's a unique ID for each token that's being generated. And then I built a toolkit here that spins up headless browsers in 2 ways. So this actually runs full video playback, spins up an HLS.js or whatever your favorite video player is, gets a stream URL with that token inserted, and then is able to go and do the video playback. So for legitimate sessions, we're spinning up a single user, a single browser session per token. In the pirate swarms that we're simulating, it's configurable to spin up 5, 10 browser sessions per token. So a lot of this I've also been using the AI tools, a lot of vibe coding, and just some of the things along the way that I think have been helpful here is when tackling initially building this, when tackling any key features, staying in planning mode and using higher end models, using your Fables and Souls now, and really providing it a lot of good feedback, getting to a really solid plan, has really helped to both get better output results and get it achieving what you wanted. The other piece was building more automated test frameworks so that it could validate that things were successful. Like when I was building the video playback with an HLS.js player, making sure that the player is able, the framework is able to run with Playwright, use MCPs, spin up real browsers, check output of logs. If there were playback issues, go back and analyze why were the playback issues there. And that really helped to also be able to run much longer loops, unattended, and get much better results out of the AI tools. So the approach that then I used on the anti-piracy side and dealing with this was using a feature that Farsi has in our edge rate limiting. So our edge rate limiting runs in every edge pop. It runs in memory. It's counters that get synchronized across hosts in each of our pops. And this is all configurable in VCL, so you can, decide how you add to counters, what windows you look at, things like that. So with our rate counters, they can track the number of request volume and number of requests over either 1, 10, or 60-second windows. And one of the unique things here with our implementation was commonly you'll use an IP address as the key for a rate counter, but in this case, we actually used the subclaim that we extracted from the cat token as that value. And then we also have penalty boxes to allow you to, if you've exceeded a threshold, to not have to keep checking the rate counter. So let's talk about then how I built this approach using edge rate limiting. So we extract the subclaim, and all of this is happening in VCL. I built a lot of this as well with our AI tooling, built the Farsi VCL Varnish services with Terraform. So we extract a subclaim from the token. We, for that request, we add to the rate counter for that particular subscriber ID. We check if we're above the threshold. If we are, in this case, initially, I've implemented it as a logging approach. So on the right-hand side, you'll see this message that indicates, this subscriber ID saw above 75 requests in a minute window, and it was in our Chicago pop. And then the idea is then tying together our piracy simulation framework with this edge rate limiting tool lets us simulate how this would act and start to figure out how to tune threshold values and other things like that. So let's walk through a really quick demo here. Okay, so here, starting up our simulator, it's running a few legit sessions there and then some of our pirate swarm sessions. So they have a number of sessions. You can see there's a cat token that was generated. This is one of our legit streams, so you can see the request there. And then we fired a detection within 20-30 seconds when we went above a threshold. And you can see there, we got above that 75 requests in a minute window very quickly when we had these 6 sessions that were running rather than one. So, this is very easy to use, very easy to tune. So there's a few pieces, now of future work in this area. Right now, this runs at a pop level, so you'll get a log line per, pop when you exceed these thresholds. We're working on how we'll deduplicate some of that data so we could send our customers, this subscriber ID went above the threshold in these 10 different pops. I'm looking at extending the test framework. Right now, it's just running from my laptop, so I hit whatever pop I'm closest to. We could run global proxies so that we could, simulate piracy coming from all different regions and different countries. And then also starting to think about how we can use this piracy framework now to test and simulate other token resharing methods. We're looking at distributed proof of possession, app and device attestation, mutual TLS, other approaches that might also help us stop token sharing even before we're having to allow it through. With this approach, this is great. You can block it on the edge rate limiting, or you can with logs figure out what you want to go and do with that. It could be pacing and slowing down, it could be content replacement, it could be blocking. So I think this provides a really useful framework for a lot of future experiments in anti-piracy as well. And then, I talked about common access token now allows us to add a lot more granular geodata. So a token could also add country limitations. But, we're seeing these VPNs and proxies starting to be more common. So edge rate limiting allows us to also start to understand where there might be gaps in some of our enforcement that we're using, and then start to tackle that more effectively. And then finally, today those thresholds that I set for the live demo, they were all, static thresholds, tuned it very much towards kind of a live streaming sort of workflow, where players are going to be, starting up, building a bit of a buffer, holding that stable. With, VOD, we might need to tune that a little bit more because you might have a longer buffer at startup time and then they stay stable. But so this was fairly quick and easy to build for particular use cases, but could have some potential cases where it returns false positives. So the next approach is going to be looking at, can we use AI tools? Can we, feed the responses of this, logging data from the edge rate limiting back into AI analysis tools to help us, understand, is this legitimate or not? And potentially looking at, like, can we combine our overall CDN access logs, QoE data, DRM data, and other things to help, tune better thresholds as part of this tooling. And that's it today. Thank you.